Welcome to Homework Lib.
In this question, we are assuming here that when we use coded messages, or when a coded message is sent, there are sometimes errors. And in this case, if you are considering that the code is actually the Morse code, like a dash could be actually a dot, or a dot could be actually a dash. And they gave us that this happened 3 to 4. Considering that, and supposing that there is like interference on the transmission with probability 1.8 as like 1, no 1.8, 1 over 8 has a dot being mistakenly received as a dash and vice versa. If we know that we have received a dot, so dot was received, we want to find what is here the, if we can be sure that actually that a dot was sent with less than 10% error rate. So what we can find is that what is the probability that we are going to receive a dot when we have sent a dot? And that is, considering that is a conditional probability, that is the probability of having received a dot given that we have, like this in the message, that a dot was sent times the probability of having sent a dot. Then we divide that by the probability of receiving a dot here. But like if you receive a dot, you have two possible scenarios. Either you send a dot or you have sent like a dash. So you have those two possible ways of receiving a dot. So this here, the denominator can be open as that the dot was received, given that a dot was sent, times the probability of sending a dot, plus the other scenario where a dot was received, but actually what was sent was a dash here, and times the probability of having sent a dash. So that is for the denominator. So with the numerator, what we have is 7 over 8 times 3 over 7. Then in the denominator, we have the same, okay? Which because they said that the error, like the probability of getting a dash when actually what was sent was a dot and vice versa is 1 over 8. So that means that we are gonna receive and send correctly the same code, 7 over 8, and the probability of sending a dot is 3 over 7. Then we do the same thing here, 1 over 8 over 7. And that is 21 over 25, which is 0.84. So in this case, this is the probability here that the message was you received. If you know that you have received a dot, the probability that actually you send a dot is 0.84. So that means that actually have 60% of error rate, not like a 10%. So the answer is no, based on this calculation. Then in the second one, we have here that if we consider that the number of events in one time unit has a mean of lambda, and we are interested in the waiting time until the first event happens, and we define that as x, we want to define the PDF of x. So in this case, if you want to say like the waiting time until the first event happens, that is the same as the probability that t will be equals to. But in this case, because we're interested in the waiting time until the first event happens, we need to then divide this probability by the expected number of events in that specific time. So that means that we're going to consider here this rate lambda prime. And it is in this case, because we can assume that the number of events is a can be defined as a Poisson distribution, then we're going to have lambda prime to the power 1 e to the negative of lambda prime. But actually here because we are considering here uh, in this case, the first event to happen, so we are gonna define here actually this lambda prime is 1 over lambda that they provided to us. So that means that the um, distribution of the waiting time until the first event happens follows a exponential distribution. And the exponential distribution here has a average of 1 over that lambda. Like what is this parameter? So that will be the answer for this question. Exponential with the parameter 1 over lambda.